a limit as x goes to infinity. If we remember, if you have big over small, it's a bunch of BS. The limit does not exist. It either goes to positive or negative infinity. If you have small over big, however, it shrinks down to 0. You have the same power on top and bottom. So you're looking at the biggest power. The biggest power rules. You have the same power. It's the coefficient. So in this case, you have big over small. So D and E. You have the same power, so it's your coefficients. Small over big, so the answer is 0. Okay, so this whole idea is that the limit as x goes to 0 from the left of f of x needs to equal the limit as x goes to 0 from the right in order for the limit to exist. From the left, we're going to negative 1,000. From the right, we're going to positive 1,000. These do not equal each other, so the limit does not exist. As we go from the left, it looks like we're approaching 1.110, and as we go from the right, we're also approaching 1.110. Since they're going to the same place, it's the number in between these two. It's whatever it's squeezing in on. Alright, discontinuous. This intuitive idea is you don't pick up your pencil, but there's 3 things that have to be true for definition of continuity at a point. For one, f of c has to exist. This is for x equals c. The limit as x approaches c of f of x has to exist. And the last thing is that the limit has to equal the value. It has to be a closed-in circle. So in this case, at b, the limit does not exist because from the left you're going to infinity, from the right you're going to 3. So at x equals b. At x equals c, the limit does exist, and the value exists, but the limit does not equal the value, so number 3 is not met. At e, the limit doesn't exist because you're going to 2 different places from the left and right. And at f, the limit doesn't exist, and the value doesn't exist. Which discontinuity is f of x? Undefined. Here we have a definition, here we have a definition, here we have a definition. All the closed-in circles. At f, however, there is no value assigned to the function. Limit as x goes to a. Okay, from the left, I'm going to infinity. From the right, I'm going to 3. They don't match up, so it's D and E. As I go to b, I'm sorry, I read it A wrong. As I go to a, as I go to a from the left and from the right, I squeeze in on 0. For b, that's the one I just talked about. From the left, I'm going to infinity. From the right, I'm going to 3. They don't match up. So it's D and E. As I go to c, from the left and from the right, I squeeze in onto this open circle, which is at 3. I'm looking at the y value over here. It matches up 3. Y values. Don't forget that. As I go to infinity, as I follow this function from negative infinity all the way over here, where are my y values going? They're going up to positive infinity. You can also say the limit does not exist here. As x goes to d, from the left and from the right, I'm approaching this circle, which is at 3. F, as I go from the left and from the right, I'm going up towards positive infinity, or you could say the limit does not exist. Either thing is right. The limit as x goes to e. From the left, I'm going to 1. From the right, I'm going to 2, so the limit does not exist. As I go to e from the right, this means from the right, so the right side of e would be this side. From the right, you follow this piece, and you're going, it's at 2. Remember the limit from the right and from the left, the one-sided limits always have an answer. You can always describe what's happening from one side. Okay, slope of the tangent line, rate of change, both of these things mean derivative. I hope you know that by now. Remember, derivative is the instantaneous rate of change of the slope of the tangent line. So it says find the slope, so it's just asking for the derivative here. So y prime is 6x plus 2. So y prime at negative 1 means plug in negative 1. We get negative 6 plus 2, which gives us negative 4. Y prime at 2 would be 6 times 2 plus 2. So 12 plus 2 gives us 14. And then part B says we need to find the derivative That's the derivative, y prime equals, if you want to rewrite this, it's x to the 1/2. So we take the derivative 1/2 x to the negative 1/2. The derivative of 4 is 0, so you don't have a derivative of a constant. If I rewrite this, it's the same as 1 over 2 square roots of x. Number 5, you have to remember when we first developed the definition of derivative, and we had 2 points. 2 points, and we drew a secant line between the 2 points. And our whole idea was if I move this 1 point closer and closer and closer and closer, it makes the tangent line become closer and closer and closer and closer to a secant line. Until finally, you have the tangent line when there's no change in x. So this is the definition of a derivative, and it's the change in y over the change in x, and you want the change in x to go to 0, so you just have 1 point. So limit is delta x goes to 0 of f of x plus delta x minus f of x all over delta x is the definition for the derivative of whatever function sits right here. So this is really asking for f prime of x when f of x is tangent. So if f of x is tangent, what is f prime of x? Secant squared. This, if you remember when we first did this, I had to multiply everything out and you canceled all this stuff out, but you don't have to do that. This is simply asking for the derivative of this function. F of x is x squared minus 3x plus 5, sitting right here. The delta x has just been substituted with the h. F prime of x, therefore, is 2x minus 3, simply using the power rule. Find f prime of x. We have to use the quotient rule because we have 2 functions of x. So it's the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. You can just leave it like this. Alright, to find f prime of x, this is simply using the power rule. Bring down the 7, lower the exponent by 1, bring down the 3, lower the exponent by 1, bring down the 2, lower the exponent by 1. Derivative of a constant is 0. Alright, this means second derivative. That's all it means. That double prime. So we take the derivative one time, we get 2x plus 3 minus 4x to the negative 2. If you rewrite this as 4x to the negative 1, negative 4, and then lower this by 1. So then y double prime would be 2 plus 8x to the negative 3, which is 2 plus 8 over x cubed. And then for part D, find dy dx. This is using implicit differentiation, which basically means every time you see a y, you write y prime or dy dx after it. So derivative of x cubed is 3x squared dx dx. But you don't have to write dx dx because dx dx is 1. And taking the derivative with respect to x. So then minus, our first guy is 2x, our second guy is y. So product rule, derivative of the first times the second plus the derivative of the second times the first plus the derivative of y squared, which is 2y, y prime, equals, don't forget the derivative of 5 is 0. So you have 3x squared minus 2y plus 2x y prime plus 2y y prime equals 0. Your goal is to solve for y prime, so you get everything that doesn't have y prime over to the other side. So we're adding 2y and subtracting 3x squared. So we get, factor out the y prime, we're left with 2x plus 2y equals 2y minus 3x squared. Divide by 2x plus 2y. So you're left with y prime equals 2y minus 3x squared over 2x plus 2y. Oh, I'm sorry, this is a negative. This should be a negative right here. Don't forget, distribute the negative. So we have a negative 2x, negative 2x, negative 2x plus 2y. their answer, the reason why their answer is different is because they simply factored out on -1. If factored out on -1, it would change all the signs here. So then it would be 2x minus 2y. And then they just crossed out the -1. So that's how they got this answer, if you're confused about that. Okay, the derivative of sine of something is cosine of that same thing. But remember, don't chew the chocolate. Keep it the same, but then times the derivative of the inside, which is times a. So remember, say sine of 5x, for instance, will be the derivative of the outside, which is cosine, don't chew the chocolate, times the derivative of the inside. And then we just write this 5 in front, 5 cosine 5x. Same idea here, just generally, what is it? F prime of x for tangent, the outside is tangent, so it's secant squared of 3x squared. Don't chew the chocolate. Then times the derivative of this, which is 6x. That's the chain rule. Alright, the graph of the derivative of the function is shown here. So this is f prime of x. Wherever we have f prime of x equaling 0, we know that's a max or a min of the function. So if you think about, if you want to make a number line, you can. Now, prime line. The derivative is 0. Those are your critical points. You have the derivative being negative below the x-axis, positive above, and then negative below, which means the function is decreasing, increasing, decreasing. This is something squared, which means this is probably something cubed, not just an estimate. But your idea is that this is a minimum because you're crossing from negative to positive, and this is a maximum. So I'm going to just use these same values here, these x values, and I know I'm going to have a minimum at this point. I'm going to have a maximum at this point. Now let's talk about the concavity. The concavity would be f double prime, and you notice the points of inflection are the maxes and mins of the derivative. Here f double prime would be the slope, it's positive, f double prime slope negative here. So you're concave up and then concave down, which means that our function needs to be decreasing, increasing, decreasing. So, and it's going to be concave up to this point in the middle, and then concave down. This is just one possible solution. Decreasing, increasing, decreasing, decreasing, increasing, decreasing, concave up, concave down. Okay, so this graph of the derivative, f prime has 1, 0 right here. And f prime is negative and then positive, which means the function is going to be decreasing and then increasing. So this right here is a relative min of the function. And then for concavity, if we look at f double prime is positive everywhere, and it looks like it's constant right here. So basically, from here to here, we're going to have just a straight line. But other than that, it's going to be concave up, because it's always positive. F double prime is always positive since f prime is increasing. So we want to draw something that's concave up everywhere, except right here it kind of flattens out for a little bit, like just a straight line with no concavity, and then it's still concave up. So this is our function, and it kind of looks like a quartic, because this kind of looks like a cubit. You're going up in power because this is the function and this is the derivative of the function. Alright, given the graph f of x, what is the value of the derivative? Okay, at x equals a, undefined, because it's a sharp turn. You can't take the derivative at a sharp turn. At x equals b, the derivative is the slope. Remember, slope. So at x equals b, the slope is negative. At x equals d, the slope is 0. At x equals c, the slope is positive. Alright, concavity, you look at the second derivative and they already gave it to us. So you find the critical values where x equals -2 and 4. We're setting this equal to 0. I test the points. So -3 would be negative, negative, so positive. 0 would be positive, negative, so negative, and then this would be positive. So we have concave up, down, up. So from negative infinity to -2, and from 4 to infinity. And then concave down will be from -2 to 4, and points of inflection are where it changes concavity. So x equals -2 and 4 are both be points of inflection since they're changed the sign. Okay, relative max and min. Well, let's get our critical values from setting each factor equal to 0. So we have -1, 0, and 2. I plug in a -2. This one's always positive, so just care about these two factors. Negative times negative is positive. -1/2 would be positive times negative, so negative. 1/2 would be positive times negative, so negative. And something bigger than 2 would be positive and positive, so positive. So we have increasing, decreasing, increasing. So your x, it just said the x value, so at x equals -1 is a relative max, and at x equals 2 there's a relative min. Okay, equation. Y'all should be wonderful experts at this by now. Point, slope. Your point would be 9 comma the square root of 9, which is 3. Your slope is the derivative, which is 1/2 x to the -1/2, which is the same as 1/2 square root of x. Evaluated at 9, don't forget to plug in the actual x value. It's 1/2 times 3, so it's 1/6. So y minus 3 was 1/6 times x minus 9. Okay, letter B. Line tangent, again point, slope. So your point is pi/4, comma the sine of pi/4 is √2/2, but we're supposed to square it. So if I square this, it would be 2/4, which is 1/2. The slope is, I rewrite this as sine of x squared. It's 2 times the sine of x, don't chew the chocolate, but then times the derivative, which would be cosine of x. And evaluate this at pi/4. Now the cosine and the sine at pi/4 are both √2/2. So multiply across, you have 2 times √2/2 times √2/2 is also 2/4. So you have 1. So your equation is y minus 1/2 equals 1 times x minus pi/4. Alright, so this is approximation, and it gave us the tangent line, so this is really easy. You don't have to do hardly any work. It gave you the line, you just have to approximate. I put 3.9, so plug it in. 3.9 minus 4 is simply -0.1. So this would be a positive 0.3 minus 2. So you get a -1.7. Alright, circular plate of metal is heated, the radius increases. So dr dt equals 0.01 centimeters per second. At what rate is the area increasing when the radius is 50? So we need the area formula, which is pi r squared. Make sure you have everything, dr dt, dA dt. Take the derivative, 3 pi r dr dt. Plug in what you know. We know the radius is 0.01. So we would have 2 pi times 1/100 times 50. So this simplifies to 1/2. So you have pi centimeters squared per second. Part B, hot air balloon rising from a field. So we have the observer standing 500 feet away, that's a constant. At the moment the angle of elevation is pi/4. The angle is increasing the rate, so d theta dt, 0.14 radians per minute. How fast is the balloon rising? So I called this y. Whenever the angle is pi/4. Now notice the angle is not always pi/4, so I did not label it as such. We have opposite and we have adjacent, so that's TOA. Tangent of theta equals y/500. The derivative would be secant squared theta d theta dt equals 1/500 dy dt, because this is the same thing as 1/500 y. You take the derivative. So now we need to plug in things we know. So think about secant is the reciprocal of cosine. So it's hypotenuse over adjacent. Or you can simply think, okay, pi over 4. At pi over 4, my cosine is root 2 over 2. It's a reciprocal, so my secant would be 2 over root 2. And we're supposed to square that, so it's going to be 4 over 2, which is 2. So this guy right here is 2. d theta dt is 0.14. 1 over 500 times dy dt is what we're looking for. So we have 0.28 equals 1 over 500 dy dt. So then times 500 times 500. And when you do that, you're going to get 140 feet per minute. A spherical balloon is being inflated, so the volume is increasing. So dv dt is 20 cubic inches per second. Anytime you see these units, it helps you know dv dt, what rate. So that's another derivative, is the radius changing when the radius is 5. So volume equals 4/3 pi r cubed per sphere. So dv dt would be 4 pi r squared dr dt. So we plug in what we know, 20 plus 4 pi times your radius, 5 squared dr dt. So 25 times 4 is 100. And so you divide by 100 pi. 20 over 100 simplifies to 1/5. So you have 1 over 5 pi. dr dt, radius would be measured in inches. So it's inches per second. Coal is being dropped into a right circular cone. So we have a cone. And it says at a rate of, so the volume is changing at 1200 cubic feet per minute. The height of the pile is always 4 times the radius. Find the rate at which the height is changing, so dh dt, when the height is 80. So, volume of a cone is pi over 3 times r squared times h. Now we're supposed to stop and see dv dt, check. dr dt, oh no. So that means we need to get rid of dr dt, so we need to get rid of this r. So you use this idea here. If height is 4 times the radius, this means 1/4 the height equals the radius. So you plug 1/4 h in right here. So be careful when you do that. Pi over 3 times 1/4 h squared times h. So don't forget you're squaring both things. So that's pi over 3 times pi over 16 h cubed. Now you can take the derivative. So dv dt, if I bring down the 3, these 3's will cancel. So, oh, whoops, I wrote pi over 16 instead of 1 over 16. Excuse me. Bring down the 3, these 3's cancel, so you're left with 1 over 16, or pi over 16, h squared dh dt. So now dv dt is 1200. Plug that in. Right here, you have pi over 16, h is 80 at this moment, so 80 squared dh dt. So we have pi over 16. This would be 8 times 10 and 8 times 10. So divided by 8, we can make this 2. Divided by 2 and make this 5. I'm just doing this without a calculator. So we need to divide by pi and 8, 5 and 10. Pi and 8 and 5 and 10. So let's see, 10 goes into this 120 times. 5 would go into 120. How many times? 5 goes into 120 times. So 24 times. And so then this would be 3. So 1 over 3. Oh, that would be 3. So 3 over pi. What are our units? Feet per minute. You can use a calculator, but just to show you algebraically how you would get it. 8 goes into 24 3 times. So that's where that came from. Alright. 14. Given the graph of g of x, find all the labeled points where g prime is greater than 0. Remember, g prime positive means g is increasing. So where's g increasing? G is increasing at b, so at x equals b. G double prime positive, remember g double prime positive means g is concave up, or it means g prime is increasing, okay? So this is the graph of g. So where's g concave up? Concave up at a. It looks like it switches to be concave down over here, so at x equals a. And then number 15, absolute minimum, closed interval. So this is whenever you have to make a chart, x, f of x. So negative 2 and 3, you evaluate each of those. So f of negative 2 is 2 times negative 2 cubed minus 6 times negative 2. So negative 8 times 2 is negative 16 plus 12, so that's negative 4. I plug in 3, 2 times 3 cubed minus 6 times 3. So we have 2 times 27 minus 18. So that would be 54 minus 18, which gives us 36. And then we need to find critical points. So let's take f prime of x, which is 3 times 2 is 6x squared minus 6. If we factor, we have x minus 1 and x plus 1. So you have x equals 1 and x equals negative 1. So they're both on the interval. You plug them both in. 1 you get 2 minus 6, which is negative 4. If I plug in negative 1, I would have negative 2 plus 6, which is 4. And so the absolute minimum happens 2 times, at negative 2 and at 1. But it's asking for the value. The value means the y. So the y value would be negative 4, even though it happens twice. So the absolute minimum is negative 4. How low does the function go? Alright, happy studying.